Hey everybody, tonight I'm talking about biofilms. So what are biofilms? They are collections of bacteria that form and accumulate in these little colonies on the surface of living, non-living material, really anything. And they are covered in this like slimy extracellular matrix. They accumulate all over your body and all over the world. They've been found in thermal features in Yellowstone National Park, like in those super hot thermophilic hot springs. They've been found in urinary tracts, in artificial knees and hips. And biofilms have also been found in plaque that covers everybody's teeth. Biofilms can form as communities of just one single species at a time. They can also be composed of hundreds of different species coming together. Like plaque alone has over 500 species of bacteria, whereas urinary tract biofilms typically have just one species of bacteria. It's usually E. coli, just the one. So over the years, scientists have found that bacteria prefer to be in these biofilm forms rather than like singular, like planktonic structure where just like one's swimming about by itself. Because being a part of this biofilm, this colony, allows the bacteria to protect each other and also to have a larger effect on whatever individual. It's kind of like strength in numbers. The more bacteria, the bigger the biofilm, the bigger of an effect and impact it has on an organism. Because the biofilm, not only is their size bigger, but they also create this like network of cellular signals to fulfill these bacterial like cellular functions. It's called quorum sensing, and we'll go more into that later. So how do these biofilms even happen? One singular planktonic bacteria will attach to a surface with the help of their flagella or pili or whatever appendage. They'll coat the surface in this layer of like glycoproteins that allow for more planktonic bacteria to come in and attach to the surface. As more planktonic bacteria bind to the surface, they form bigger colonies creating a biofilm. And then that allows them to communicate and network using the quorum sensing chemical signals. Then it produces this extracellular matrix with lipids and proteins and polysaccharides to protect the colony in like a gelatinous, havoc-wreaking matrix. Additionally, this colony, actually, while it provides protection, it can also dissolve at any point and like release a singular planktonic bacteria to go transfer to another surface where there's more nutrients and create a whole nother infection on a different surface. Great. Biofilms usually form where there's a lot of nutrients passing through for the bacteria, but they can also transfer to other locations where there are more nutrients readily available. So how do biofilms coincide with antibiotic treatment failure? Bacteria and biofilms are sometimes up to like hundreds of times more resistant to antibiotics than planktonic bacteria. This is partially due to the protective slimy matrix that forms around the biofilm colonies. They're also able to communicate genes for antibiotic resistance from cell to cell thanks to that quorum sensing like network that they have. I found this fact today that's fascinating. Sometimes it only takes up to like 6 to 12 hours for these colonies to become completely resistant to resistant to antibiotics. It's fascinating, but also like sort of mildly horrifying that it's that quick. So with this antibiotic resistance, biofilms can also be resistant to immunity cells for similar reasons. The immune cells can just kind of like whack away the planktonic singular bacteria, but they have to go up against way more when they go up against this biofilm. And they also have reduced efficacy against the like matrix that forms around the biofilm. Biofilms can also lay dormant and like therefore hidden to the immune system for like months or years. Crazy. So what do biofilms have to do with like hospital-acquired infections? So 80% of bacteria are actually accumulated in the form of biofilms. and 60% of hospital-acquired infections are due to biofilms. So bacterial biofilms are typically pathogenic in nature, and therefore they have an increased chance of spreading in an area of high disease, like a hospital, for example. And they have the potential to continue to spread if they're not eradicated and wiped out by the appropriate chemicals, the appropriate antimicrobials, and then it just continues to pass on through patients. So back to the cellular signals, the quorum sensing. So the quorum sensing refers to the intercellular communication that's developed within a biofilm. It allows for detection and sharing of cellular information, for example, cellular density or bacteria resistance and regulating disease mechanisms. And then they can adjust what genes should be expressed based on what information they received. So what methods are used for controlling these biofilms? So an example that I found that's pertinent to many women is recurring urinary tract infections. So there's a company out there called Eucora, and it's been created for over-the-counter prophylactic treatment of UTIs because bacteria built up in the urinary tract and the bladder and eventually creates this large biofilm that's resistant to a lot of regular UTI antibiotics. So this company, Eucora, has a number of products, but one of their products is specifically designed to cleanse the biofilm, which I never understood what that meant until this week. So there are a few ingredients. They have green tea extract and the most talked about recently called D-mannose that supposedly cleanses the biofilm because the D-mannose can bind to urinary microorganisms and then make them unable to attach to the wall of the bladder, actually. Apart from this company, though, later generation antibiotics like cephalosporins and aminoglycosides have also been shown to reduce the biofilm biomass in the urinary tract, therefore being more effective. So, all that being said, while biofilms sound awful and can be obviously lethal, researching and understanding the quorum sensing that's happening intracellularly can potentially actually help humans control and maybe even further manipulate the bacteria to not only be less lethal, but actually beneficial to humankind.